So, wonderful good evening, everyone. I welcome you back to my YouTube channel, and presenting before you this wonderful tutorial is the mentor Hampel Kliman. And of course, today I bring you a very important tutorial under continuity of limits. And of course, if you want to register for personal lessons, it's just +2607766 4046. That is my WhatsApp number. You can just inbox me on WhatsApp and I'll be able to register you. That is if you want to join tuitions at Etsy Learning Academy, where we offer all courses. Now listen, I come with a very interesting concept because many people have received quite a lot of text from students. They're saying, Mentor, how do you solve questions under limit and continuity under calculus? How do you simplify everything? Well, I'm going to give you a very simple concept. Now look at this. How exactly do you know that a limit is continuous at a certain point? Look at this. The whole concept is like this. You take the limit as x approaches some constant c. When the function of f of x is equal to some L, then we say that the function of the absolute value of some function f of x, as we approach a value which we are calling as epsilon in the x-axis, then we say that as we approach a value in the x, there has to be a certain value that we are going to be approaching in the y. Well, not to be complicated, but look at this. If you take the limit as x approaches some constancy, when the function of f of x is going to equal to some L, then every time we approach a certain value in the x-axis, we shall be producing some value within the y-axis. In other words, limits and continuity is just there to help you assess or understand exactly what value you will be approaching in the y-axis as you approach some c in the x. Look at this. If at all I was to draw a diagram of this particular type, right? And then this becomes my x-axis. This becomes my y-axis. Okay, then this becomes my 0. What does this imply? If this was my 1, my 2, my 3, then this becomes my 1, my 2, my 3. If at all this c was a value, let's say 2. So we have the limit as x is approaching some 2, right? So as we approach some 2 like this in the x-axis, I want to approach 2. As I am approaching 2 in the x, you discover that there is a certain value I am approaching in the y, right? Now, when we bring in the concept of continuity, I'm just trying to understand in my journey of approaching 2 in the x-axis, was there a point where I had to find a river, right? Imagine you find a river and that river is full of crocodiles. The only option that you have is to either get a canoe or jump that river, then you continue on moving. Now, functions have got a behavior of performing in such a way. They can have a hole somewhere, right? They can have a hole somewhere which you are calling as an asymptote, okay? An asymptote which you should be able to take into consideration. Now look at this. If at all there is a hole somewhere, then this particular function is not continuous at some point, right? It's not continuous at some point. But the truth of the matter is, as we approach x somewhere in the x, there has to be a value we are going to be approaching somewhere in the y-axis. So the law of continuity under limits is for us to be able to assess the behavior of a function, or be able to see where a function is basically going to be continuous. Now, how are you going to solve? When exactly is a function continuous? A function is going to be continuous when the limit as x is approaching some c from the negative side of the function of f of x is equal to the same limit as x is approaching some c from the positive side of the function of f of x, right? Now, this whole concept is going to be simplified by a piecewise function, because in your semester 1, I was able to teach you how to be able to generate equations using equations and set them in a piecewise function. But this time around, they've already formed an equation for us, but we just have to determine where the function is continuous or where the function is discontinuous. We shall be using this concept to be able to solve questions. How do you solve problems using the concept that has been highlighted? Let me show you something. Let me be able to give you precisely how to be able to interpret whether this is on the right, this is on the left. I want you to look at the first equation that has been given. You have x less than 2. Please, I want you to take this interpretation. You can use it for anything. You have x is less than 2. Then the second one, you have 2 less than x less than 2, right? Okay. Sorry, less than 3. Supposed to be 3 here. Then the third one, you have x greater than 3. The first observation that you should make is there are only two values to which x is being defined at. 2 and 3. So your defining point is x must equal 2, x must equal 3. That's the first point you must put in your head. Now, if at all you started interpreting 2, if this is your 2, then they say x must be less than 2. It implies that your x is this side. Okay, this is less, this is great. So x less than 2 is this side where it's negative, right? Then we come to the second part. The second part, they're saying 2 must be less than x, meaning x is on the positive side of 2, because 2 must be less than x. So meaning it's on the positive side for this particular guy. Then x must be greater than or equal to 3. Then that implies that for this particular equation, x is where? On the positive side. In terms of 3, if we're defining at 3 now, x is on the positive side for this particular expression. How about for this particular expression, in terms of 3, we forget the 2 now. Let's just focus on 3. They are saying x must be less than 3. Okay? X must be less than 3, meaning x should be on the negative side of 3. So for this one, your x is on 3, is on the negative side of 3. That is in terms of this number. Then for this equation, in terms of 3x is on the positive. That is the whole idea I want you to put in your head. Now let me try to use this concept. I show you how you generate your equations. We shall use the same concept I have given you. What are the defining points? The defining points are 2 and 3. So we have x is equal to 2 and that x is equal to 3. Now we are going to use the first equation we determine. We can only have a continuous, we can only have continuity of a function at limit if we take the limit. So we are defining 2. Limit as x is approaching 2 from the negative side of the function of f of x must equal to the limit as x is approaching some 2 from the positive side of f of x. That is correct. Now, in terms of 2, where exactly is x less than 2? Okay? Where exactly is x less than 2? X is less than 2 by this particular condition. So it is this equation we are going to get. We are going to put it where there is f of x. So I'm going to put that equation there. So I'm going to say x to the power 2 minus 4 over x minus 2. Then this must equal to, here they are saying x must be greater than 2. So meaning x is on the positive side of 2. Where exactly? So here there's the condition is saying 2 must be less than x. So 2 is smaller than x, meaning x is on the positive side of 2. So on the positive side, we use that equation there. Now notice that the top part, you can change it in this way. When you factorize, then this side you're going to have ax to the power 2 minus bx plus 3. So this and this can cancel. Then you're going to have x plus 2 is equal to ax to the 2 minus bx plus 3. Now, we are defining it at some point 2. So I'm going to put 2 everywhere where there is x. Same concept for everything and for every question. Then this is going to be 4 is equal to, this is going to be 4a minus 2b plus 3, which is going to be 4a minus 2b. Then when the 3 crosses and it comes this side, it will be 4 minus 3, which is 1. You take this one as your equation 1. Now, we go to the next one. We define it in terms of 3. We use the same concept. Limit as x is approaching some 3 from the negative of the function of f of x is equal to the limit as x is approaching some 3 from the positive side of the function of f of x. Now, where exactly is x less than 3? X is less than 3 on this equation because they're saying x must be less than 3. So we are going to put this equation where there is f of x. Then where is x greater than 3? It is this side. Okay. Then you can put your 3 everywhere where there is x. This is going to be like 9a minus 3b plus 3 is equal to 6 minus a plus b. Now let's try to make the equation properly. If this a crosses the equal sign, it adds to 9, it becomes 10a. This is minus 3b. If the b crosses, it comes this side, it becomes minus 4b. Then the 3 goes this side, it will subtract from 6, it becomes 3. We have 2 equations. Now we can solve them simultaneously. The first equation we had was 4a minus 2b is equal to 1. The second one is 10a. Okay. 10a minus 4b is equal to 3. So your 4 goes on top, your 2 comes here. You swap them. This one comes here, this one goes up. Then you're going to have 4 multiplied by, okay, 4 multiplied by 4, it will be 16. A minus 4 multiplied by 2, it's going to be 8b equal to 4. 2 multiplied by this is going to be 20a minus 2 multiplied by that is going to be 8b equal to, this is going to be 6. Then the only way you would be able to cancel these two is when you subtract. So when you subtract 16 minus 20, it is going to give you minus 4a. This part will give you 0. This part will give you negative 2. So a is equal to 1 over 2. Then you can just get any of the equation, which is very simple. So I can get the top equation so that I have 4. Then inside that I put 1 over 2 minus 2b is equal to 1. Then this is going to be like this into this. That's 2. So 2 minus 2b is equal to 1. So minus 2b is equal to 1 minus 2. So your b is equal to, okay, your b is equal to 1 over, okay, 1 over 2. Okay. Let's try to check if it will give us 1 over 2 even for the other one, just for the sake of confirming if what I've done is correct. So we've got 10, then 1 over 2. Over 2 minus 4b is equal to 3. So this and this will give us 5 minus 4b is equal to 3. So minus 4b is equal to 3 minus 5. This will give us minus 2. So your b will still give you 1 over 2. Okay, so for this particular function to be continuous, your a must be equal to 1 over 2. Your b must equal to 1 over 2. Okay, that is how you are able to calculate this particular question. Okay, we go to the second question. We shall use the same concept. Find the values of a and b for which f of x is continuous. Now, let's assess at what point are we defining it. We are defining them at x is equal to 1 and at x is equal to 4. Yes? Now, let's try to see what equation can we get if we define it at 1. So the same thing, we start limit as x approaching some 1 from the negative side of some function of f of x is equal to the limit as x is approaching some 1 from the positive side of some function of f of x. Then you check where exactly is x less than 1. It's this equation. So you're going to put that equation there. Where is x greater than 1? Look, 1 must be less than or equal to, okay, 1 must be less than or equal to x, meaning x can be 1 or it can be greater than. Those are the possibilities. So this one is on the positive side of x. Then from there we can put some 1 where there is x. This will just be like that. Okay, then from there we are going to have a minus b is equal to, notice that this is 1 and this will cancel, so I'm just going to have a 2 here. We can say this is equation 1. Let's try to define it at some 4. Where is x? Okay. We do the same. We take the limit as x is approaching some 4 from the negative side of some function of f of x is equal to the same limit as x approaching some 4 from the positive side of some function of f of x. Then where exactly is x less than 4? It's defined at this point. So you can get your bx plus some 2. Then you're going to equate it to where exactly is, okay, is able to show, right? X is greater than 4. Then you're going to get some x plus some a minus some b. Then you can put some 4 where there is x. We see how it's going to be. Notice that this is going to be 4b plus 2 is equal to 4 plus a minus b. Okay, let's try to check if we can cancel anything. So let's have 4b here. The b goes this side, it becomes a positive. The a goes this side, it becomes a minus. We have a 4 there, minus 2. Then this is going to be like 5b minus a equal to some 2, right? Let's try to solve them simultaneously. So we're going to have our, this is equation 2. So let me solve them simultaneously. We see if at all it's going to give the mentor anything sensible. We have a minus b equal to 2. This side we have 5. Come on, no need. So what can we do about it? We can write it properly. So you can just say this is going to be minus a plus 5b. Wait a minute. Let me use the color that I was using there first. Okay, so this is going to be minus a plus 5b is equal to 2. Same concept. This goes this side, this comes here. So this is positive 1. Just don't get the negative sign, just get the coefficient 1, 5. Then we multiply. So this is going to be 5a minus 5b equal to 10. This is going to be minus a plus 5b equal to 2. As long as the signs here are different, just add them. 5v plus negative a, it's going to be 4a. This part will give you 0 if you add. This part will give you 12 if you add. Over 4. Your a becomes 3. Then you can find your b. So a minus, come on. So your a is 3. We are using the upper equation, which is this one. Minus b is equal to 2. So this is going to be minus b is equal to 2 minus 3. Of course, which is going to give me minus b is equal to minus 1. So your b is equal to 1. So for this particular function to be continuous, a must equal to 3, b must equal to 1. And you get your full 8 marks for that. Found this video interesting and helpful, consider subscribing, hitting the like button, and don't forget to share to others. Jesus loves you so much. The mentor Hampel Kleeman signing out. Thank you.